Welcome to my YouTube channel. In this video, we're going to be discussing domain and range as it concerns trigonometric functions, and our focus will be on sine, cosine, and tangent functions. Now, and it will be easier for us to understand it using the graphs. And then, what's domain? Domain are the set of possible input values, and while range are the possible output values. And again, domain can also be defined as all the values that can go into a function in order for that function to be defined. While range is also the outcome of a function when you have plugged those x values. So let's start. Now, this is the end behavior of a sine graph. And how do you find the domain and range of a sine, or let's say the domain and range of sine theta, using the graph of sine theta? Now, looking at this graph, you can get the domain of this graph by considering all the x values that are possible in this graph. Now, if you look at this graph now, you can find out that this sign here now, this behavior now, this line here now, goes from negative infinity to positive infinity. That's why I put arrow here and also arrow this place. So, and domain are the possible x values. So if you check this graph now, this is the x-axis and this is the y-axis. Now, what are the possible x values that will satisfy this graph, this sine graph now? So if you take a close look at this thing now, this line here now goes like this all the way to infinity, while this one goes like this one to way to to positive infinity. So what can say that the domain of sine theta is domain is equals to negative infinity to infinity. And then there's difference between this bracket. This is parenthesis and this one is bracket. So use this bracket when the number you're writing with it is not inclusive, and use this bracket when the number you're using need to close is inclusive. Now this is parenthesis and this is bracket. Yeah. So the domain of a sine theta is negative infinity to infinity, and it is open because as infinity is not a specific number. You understand? So what's the range of a sine function? Now, if you look at this graph now, you find out that this line goes like this all the way to 1 and start coming down, then all the way to negative 1 again. You understand? It stops here and it just stops here. So that's from negative 1 to 1. So we can now write that the range of a sine function is from negative 1 to 1. So this is a bracket because it includes 1, from negative 1 to 1. So that's the range of a sine function. So what this thing is clearly telling us now is that for any value of x or theta you plug in a sine, the outcome, which is the range, is going to be between negative 1 and 1, because sine 90 is equals to 1. And how is it that sine 90 is 1? If you look at this graph now, sine 90, if you follow this line now, sine 90, and trace it to the y-axis, you can find out that sine 90 is 1. And then sine 180 is 0 because 180 is at the positive x-axis. So sine 270, if you trace it down, you find out that sine 270 is negative 1. And then sine 360 is 0 because this, according to this graph now, this graph cuts the x-axis at 360 here now. So this is how you find the range of sine theta. So let's talk about cosine theta using this cosine graph. And if you look at this graph now, the end behavior of this cosine theta is that it starts from positive 1 and then come down and go. This line cuts the x-axis at 90 degrees and then come up from 270 and then cuts again at 270, then come up, and that's how it will keep on going. The same thing is applicable to the negative x-axis. So what's the domain and range of this of this cosine graph now? So what's the domain and range of this cosine graph now? The domain or the cosine graph is the same thing as the sine. So this line here goes all the way to infinity, while this one also goes all the way to infinity. So the domain of this of a cosine is from negative infinity to infinity. It means that all the x values, all the values from 1 to anything, or from -1 to anything, you can plug it in cosine and still get an answer. So what's the range of a cosine theta? Now if you look at this now, the same thing is applicable to also the sine. So this line here now comes down like this, from it touches the -1 and then goes up again. This one also comes down like this, touch the -1, goes up, touch 1 and go down and come down. So you can find out that the range of cosine theta is from -1 also. This is a bracket from -1 to 1. That's how to find the domain and range of cos theta. And it also shows that for any value of theta that you plug in cos theta, you are going to get values of from -1 to 1. You can't get anything outside these values. So let's talk about tangent graph or tangent function. Now this one is a little bit complicated. Why I say that is because it will be easier for us to find the range of tan theta than that of the domain. Now let's start from range first. If you look at this graph now, this is the x-axis and this is the y-axis. This is the y-axis. I mean, this is the x-axis, while this is y-axis. So, and our range are the possible y values. That's the outcome, because y is the outcome. So, according to this graph now, the behavior is that this line starts from here now and goes down, and then it goes to infinity, while this one now comes down to infinity. The same thing is applicable. This is how it is from negative infinity to positive infinity. So we can write our range as negative infinity to infinity. And then what about the domain? And this one is a little bit complicated, as I've said before. So how do you find the domain of tan theta now? As you can see, the tangent graph has vertical asymptotes at 90-degree interval. It has at 90 degrees, and it also has at 270. Now this 90 degrees is the start of the asymptote. Now another asymptote occurs at 3 times 90 degrees, which is 3 times 90, which is 270. Then another vertical asymptote occurs at 5 times 90, which is 450 degrees. So that's how it went on and on. And this one also, from the negative axis, it occurs as minus 90 at minus 270, minus 540, 550, or then to the end. And from here, it occurs as minus 90, minus 270, and then 5 times 90, which is 5 times 9 is 45, which is 450 degrees. And then it continues like that in infinity. So how do we write out the domain of this function now? Now the domain of this function is, we are going to write it as, remember, this is from negative infinity to positive infinity. So the range, the domain is we're going to write it as real number minus. Now how do we remove all these vertical asymptotes here? How do we remove them? Okay, we are going to write real numbers minus n. We're going to write it as n pi over 2. Yeah, because, and then we also write where n is a negative integer. So where n is a negative integer. So what do I mean by a negative integer? We know that integers are positive or negative whole numbers. Sorry, I mean where n is an odd integer. So how do I mean by odd integer? Odd integer means 1, 3, 5, 7, and then negative integers are also -1, -3, -5, and so on. So it means that n pi over 2 is not included in the domain of tan theta. Now let's try it. 1 times, and then pi here now is equals to 1/8. So 1 times 180 over 2 is the same thing as 180 over 2, which is equals to 90 degrees. Now, remember we're talking about odd integers. So another odd number is 3. 3 times 180 over 2, which is equals to, now 3 times 180 over 2 is 90. 3 times 90 is equals to 270, which is this asymptote we have here now. So another one is 5 times 180 over 2, which is equals to 5 times 180 over 2 is 90, which is the same thing as 450 degrees. So this 450 is another line we have here, another asymptote we have here. So this is how it continues on and on to infinity, and then to the negative axis, this is how it continues to negative infinity. So this is how to find the domain and range of sine theta, cos theta, and tangent theta. Please remember to like this video, comment, share, and subscribe to my YouTube channel for more videos. Thank you for watching. Have a nice day.